For this partial fraction, we need to split this apart into a x factor part and an x squared plus 9 factor part. Now, when we do that, we have to recognize that the x squared, the quadratic part, if the discriminant is less than 0, this is an arctan type. And so I've got the arctan formula over here when we're going to integrate this. And we need to know how to split up this partial fraction into an a over the linear term and a bx plus c over the quadratic term. In this case here, we have then our a. Our a is going to be over the x term. And we're also going to have a bx plus c. And that's going to be over the quadratic term. In this case, it's x squared plus 9. And then we need to solve for a, b, and c. So my system of equations looks like this. So my equation, first of all, is ax squared plus 9. And we're going to end up with plus our x times the bx plus c. And that's going to be equal to my numerator term, which is that term here. And that's going to be, when I expand that out, 3x minus 18. Okay, and so that is going to be from the numerator. Now, to solve this, we can try some shortcuts here, because since we have an x factor, we can actually choose our factor, our x to be equal to 0. And what that will end up doing is it will simplify our equation. So if we let x equal to 0, what I'm going to end up with is a times 0 squared plus 9, or a times 9, plus x is 0, so we're going to end up having a 0 multiplier, and this just becomes 0 times c. That's going to be equal to, again, we're going to have a 0 in this. We're going to substitute x is 0. So we end up being able to solve for a fairly easily. So we end up with 9a is equal to negative 18. We end up with a is equal to negative 2. So that's kind of a quick and easy way to solve for a. Now for the rest of this, we can probably expand this out and generate some common factors. So in this case here, I'm going to expand this out. So once I have my a equals negative 2, I can start again from here, and I can expand this out. I get ax squared plus 9a plus bx squared plus cx. And that's going to equal negative 18. Okay, now we can see that the a has already been solved for, so I'm going to replace that a with a negative 2. So we have negative 2 x squared and negative 9 times negative 2. And grouping some of my like terms together, we're going to end up with, need to make sure that I have my 3x minus 18 here, or 3x minus 18 from that original line. And I can see right away that my c is going to be equal to 3 by equating coefficients. I can equate the other coefficients, and that I end up with, and maybe I'll do this in a different color here. Maybe I'll do this in green. When I group together these coefficients, I know that there's a 0x squared. So I end up with negative 2 plus b must be equal to 0. Equating the coefficients on maybe I'll put that here, 0x squared Okay, and then we can also equate the other coefficient here. The cx must match the 3x, so we can see that c is equal to 3. So we have c is equal to 3, and we also get b is equal to 2. So there we have all three coefficients. So my partial fraction then can be broken down into this. So we end up with a, which is negative 2, over x plus our bx plus c, so our b was 2, so we end up with 2x plus c, which we worked out to be 3, and that's going to be over our x squared plus 9. Okay, and I'm just going to convert that to black because there's no real reason to have that color-coded like that. Okay, so there's our partial fraction. We're going to then integrate these terms and work out the integral. So for the integral for this part here, this is a log integral. So I'm just going to do that right away. So I get negative 2 log x. For this second part, we need to split this up into two parts. We need to have our substitution part. So to figure out our substitution piece, we take that and we let u equal x squared plus 9. That means we get a du that's equal to 2x. And any leftover piece then we put into the arctan piece. Okay, so once I've matched my my du, I can now split it up. So I have my substitution piece. It's going to be the 2x over x squared plus 9, which I've already set up the substitution for, plus the integral of 3 over x squared plus 9 dx, and this is going to be the arctan part. So I'm just going to label this. This is my substitution. And this portion here is my arctan part, and which I need to have that formula for. Okay, and just going to color code this a little bit. That goes with the red part. So I've already done the log portion of this, so I'm just going to continue, make sure I bring that down. Negative 2 log x plus the substitution. I'm going to end up with the 2x dx is going to be replaced with a du in the numerator, and in the denominator is my u, so that just becomes log u. For the arctan portion, I'm just going to set it up like this, 3 over x squared plus 3 squared, and maybe I'm going to bring the 3 out to the front so that it's just a little bit easier to see how it fits into the formula. And I can see from my formula that's going to be, I have a squared plus x squared. A is 3, so I'm going to use that coefficient when I integrate this. So again, carrying my negative 2 log x down, plus this portion becomes log of u, which I'm going to replace with x squared plus 9, plus this portion here now becomes 3 over 3 arctan of x over 3, and then we have our plus c involved in here as well. And that extra 3 here and here come from the 3 in here. And that's directly from my formula. If I take a look at my arctan formula, it's 1 over a squared plus x squared, and that's equal to 1 over a and then x over a. So the last step is I'm just going to replace my u So my final answer is going to look like this: log x plus log of x squared plus 9. I don't need the absolute value because that's going to always be positive, plus arctan of x over 3, and then plus c. Okay, so I've applied my partial fraction to this, and then I integrated what's left over. When I'm integrating the arctan part, or this portion here, just making sure I know how to break that up into its substitution portion and the arctan portion.